So let us continue this session. Rate of chemical reaction. So what is the meaning of rate of chemical reaction? So as we already discussed, it is speed or velocity with which a reaction take place. It is nothing but the speed or velocity with which a reaction take place, and it can be expressed qualitatively as well as quantitatively. How we can see? So there are two rates. One is qualitative rates and second is quantitative rates. Meaning is that it is this qualitative rate means it is based on a certain visual parameter. It is based on certain visual parameters. What are the parameters? That is the disappearance of reactants, color change, effervescence. I hope that you know the meaning of all these things. So this is the bubbling sound. This is the color change. This is the concentration of reactant decreasing. So these are the parameters which decides the qualitative rate. The rate expressed as such provides the arbitrary conclusion about the rate of reaction. So we can give this arbitrary conclusions that the reaction is going on. Second is quantitative rates. Quantitative rates means it provides us with much better information about the rate data. So actually from here we can understand the rate data and accurate rate of a reaction, that is decrease in concentration of the reactant or increase in the concentration of the rate of product. Rate of increase in concentration. So here product concentration increasing and here reactant concentration is decreasing. So we will get the data. Here we will get the data, here we will get the appearance. So both are different to each other. Now let us take one hypothetical example to understand there are different rates of chemical reaction, that is average rate and instantaneous rate. We have two types, average and instantaneous. So suppose a car which is going to some A to B distance. So from A to some in middle the car has traveled x miles, and from here it is traveled some another distance. So from this to this distance is y miles. So from here to t time is x mile, again it further reach to B destination with covering some more distance. So from 0 to this distance is y miles. So here time is t2. So he has started at 9 am and he reached this destination 11 am. So what is the rate of the velocity of the car? So we write here change in distance by change in time. Means whatever rate of velocity, change in distance by change. So from here to here, what was the rate? So we can write here from this to this point. Suppose this point is suppose 0, or you can say O. So what was the average rate of car from O to B? So that is the difference in distance by time. So time is t2 minus t1 and distance is here. This is y minus x. So y minus x, or you can write the time interval 11 o'clock minus 9 o'clock, that is the time interval, and you will get the velocity of the car, that is the y minus x by 2. This is the 2 hours miles per hour. So from here what we see that the car has been driven with uniform rate. The car has been driven with uniform rate, but actually it has been driven sometimes faster and sometimes slower, depending upon the condition of the road. Sometimes lower, sometimes. So it depends on the condition of road. You can see this is one of the factors. Thus the overall rate is an average rate, and the rate at which the car was moving at any instant. So I am marking it at any instant, means at a particular instant of time. That is the instantaneous rate was changeable. So we will get the two type of rates. One is called the average rate and second is called instantaneous rate. What is average rate? So average rate is the rate measured over a long time interval. When you are taking the time interval a long time, and the rate is measured on that long time interval is called as average rate. And if the rate is measured for the infinitesimally small time interval, means the time interval is very very small, that rate is called as instantaneous rate. So in chemical reactions, reactants is converted into products. So what happens? Reactants are consumed because concentration of reactant decreases, and the second thing is that concentration of product increases. Why? Because the products are produced. Expression of the rate of a reaction in terms of reactant product. So here already we discussed that we have two types of rate. One is average rate and instantaneous rate. So again this average rate is nothing but the ratio of the total change in concentration to the total time taken. We will see through this graph more accurately and more properly. So here I have drawn two diagrams. You can see here this diagram is, from this is the reactant from 0 point is, from here it is decreasing, you can say decreasing here. So there are 2 points. I have taken this one concentration, this is the R1, this is the R2, this 2 point on this curve graph. So R1, R2 is nothing but this is the R1 and R2. So you take the difference in concentration. So and from R1 this is time T1, this R2 is time T2. From here to here, this is concentration versus time graph. So in concentration versus time graph, average rate will equal to change in R by delta T, time interval, and change are nothing but the R2 minus R1, which is give you a negative. Similarly, in case of product, this is increasing, this is decreasing, this is increasing. So there are two concentration I have taken. This one, this is P, this is P1, this is P2. This is time interval T1, this is time interval T2. So again, for this average rate will be delta P by delta T, and this will be your P2 minus PT by delta T. This is that again concentration for the time interval graph. There is one more rate is there, that is called instantaneous rate. So for instantaneous rate we require one slope. Slope means you take any point. This point it is coming at t time. So this t time, how to find the slope? Slope is you have to draw one tangent. If you draw the tangent and you take this, make a triangle. If you make a triangle, so this distance will be your small dr, and this is your small dt time interval. So when you take this time interval dt and dr, and this will give you slope, and this is the angle theta. So angle theta is always giving the slope of the instantaneous rate. So from slope we can find the instantaneous rate of the reaction. Similarly, in case of products, so you take the tangent over this curve. So you take tangent, again you draw this triangle. So this theta will give you the, it's called tan theta. Tan theta is nothing but the delta dp by dt. So instantaneous rate will be derivative of p by dt will give you the slope, and this slope will tell you the instantaneous rate of the reaction. So mathematically, I hope that you have studied these topics. So you can calculate the tan theta, and in this way we can find the average and instantaneous rate of a reaction. So let us take one hypothetical equation to understand this concept more clearly. So reactant is converted into product. So let us take reactant 1 mole and let us take product 1 mole. So 1 mole of A is reacting with the 1 mole of B. So what will happen? The rate of decrease in A. So here consider A should be equal to the rate in increase in B. So AB means nothing but the reactant is A and this is the product is B. So average rate of consumption of A is equal to average rate of formation of B. So we can write here minus delta R by delta T equal to delta B by delta T. Second, for instantaneous rate of reactions. So in chemical kinetics, actually average rate is not much useful. Why it is not useful? Because it covers a long time interval. We are taking the long time interval during which the rate of reaction changes significantly. So to make it more useful, the time interval must be as small as possible. If you take the time interval very small, that is delta tends to 0. So when this delta tends to 0, then change in concentration is also very small. Very small means this becomes your concentration is d derivative of this small concentration, and their ratio refers to instantaneous rate. So we can define instantaneous rate of reaction, that is the rate at a particular moment. It is a very small time interval, and it is the ratio of the concentration change to time during a infinitesimally small time interval. So we can write instantaneous rate is equal to concentration, that is d of concentration by dt. So here I have done when the reactant is converted into products. So two graphs are there. This graph is concentration versus time. This reactant is decreasing, this product is decreasing, and this dot point, this give you slope. The slope will tell you the instantaneous position for the reactant, and this slope will tell you the instantaneous position of the product. And again, this is the rate versus time. This is the concentration versus time, and rate versus the both are here. So if you take for this reaction, when reactant converting to products, if you take an infinitesimal small intervals of time, that is dt. So it may be assumed that the rate is uniform throughout this interval. You have to assume this thing, rate is uniform throughout this interval, and if dx is the amount of substance, that is R is converted into product. So during this time interval, the instantaneous rate of consumption of A at that instant is given as dx by dt. So dx by dt means that the limitation of delta x by delta t, this delta x by delta is nothing but the average rate from mathematical point of view, and delta t tends to 0. So this is written as like this also. Limitation of delta t tends to 0 means is decreasing, and average rate is this one, and this is equal to dx by dt. Or in differential calculus we can write like delta x by delta t, then when delta t tends to 0 equal to dx by dt. So these are the mathematics parts. I am giving briefly hint. You can consult with some math teacher. On the other hand, for the increasing product, increasing concentration of product, that is equal to dx by dt. So we can write overall that minus dr by dt equal to derivative product by concentration product by dt. Or in terms of this one calculus, we can write limitation of delta t tends to 0 equal to minus dr by dt equal to limitation of delta t tends to 0 equal to into delta p by delta t. So this is in terms of mathematics for the writing instantaneous reactant and product rate of reaction. Mathematical expression of for rate of reaction. So we will take the example of average rate. So let's take example NO2 CO2 is converted into carbon dioxide and nitric oxides. So their condition is the coefficients of all the reactant products are the same. So if you take 1 mole of nitrogen dioxide and 1 mole of carbon monoxide, so it will give you 1 mole of this and this. So rate of reaction is given by in terms of average rate. This is nothing but the rate of disappearance of NO. This is for CO and this is for CO2. So all will be equal to each other because rates are equal. Disappearance rate is equal to rate of appearance. So we can write in terms of average rate, that is the minus of delta NO2 by delta T equal to minus delta CO by delta T, delta CO2 by delta T, delta NO by delta T, because all are 1 mole. So we can write per mole. This is the rate of disappearance of disappearance of reactant is equal to rate of appearance of the product per mole. So all these are per mole. So since here this is NO2 is a brown gas, so we can see the rate of reaction is easily measured by changing intensity of color. The intensity of the color will be changing because it is converted to nitric oxide. The color will in the gaseous mixture, the color of the brown gas will be decreasing in a given interval of time. So there is a second reaction in which we can take the different stoichiometric coefficient of reactants and products. So let us take one example like H2 plus I2 is giving 2Hi. So here you can see this is 1 mole, this is 1 mole, but this is a 2 mole. So in this case, the rate of formation of Hi will be twice the rate of disappearance of H2 and I2. So now in order to avoid the difference between two rates, in order to avoid the difference in two rates, that is to get a unique value of the reaction rates, irrespective of the species selected, so we can divide the rate of concentration by stoichiometric coefficient of reactant or product involved in the reaction. So 1 mole is giving 1 mole reacting with 1 mole to 2 mole. So this reactant is double. So in order to make equal to this one rate, we have to divide this whole rate of reaction divided by 2. So we can write here rate of reaction is equal to minus delta H2 by delta T equal to minus delta I2 by delta T is equal to 1 by 2 into delta I by delta hydrogen iodide by delta T. This is also 1 mole, this is also 1 mole, and if you divide by T, so this is also become per mole. So per mole appearance of product, per mole disappearance of product, per mole disappearance of reactant. So disappearance of reactant, disappearance of reactant, and appearance of product. Similarly, we can write here 2H2I2 is giving decomposition of hydrogen peroxide. It will give you water plus oxygen. So 2 mole, 1 mole. So in terms of average rate, we can write 2 moles of H2O2 decomposed to give 1 mole of oxygen in the same time interval. And to make rates equal, we divide the peroxide, hydrogen peroxide by their respective stoichiometric coefficient. How? See here, this will be your minus 1 by 2 of change in concentration of the H2O2 by change in T equal to 1 by 2 of change in concentration of water by delta T, and this is equal to change in concentration of oxygen by delta T. Now here one more thing you have to keep in mind, that is we do not take the concentration of water. It is ignored. Why? Because in this reaction the concentration of water is very small and it can be negligible. So this you cannot write also. This is also negligible. So we can write only this and this. Let us take one more example. 2N2O5 decomposed to give you 4 nitric oxide plus oxygen. So how we can write in terms of average rate? It is minus half of delta N2 O5 by delta T equal to plus 1 by 4 into delta NO2 by delta T, that is equal to change in concentration of oxygen by delta T. So similarly, for a hypothetical reaction, any hypothetical reaction we can write, so A concentration of A, B is giving C to D, so rate of reaction will be 1 by A into change in concentration of A by delta T equal to minus 1 by B into change in concentration of B by change in concentration by time interval equal to 1 by C into delta C by delta D, 1 by D into delta D by delta T. So here I am missing delta, let me write it. So we can write for any general reaction like this. So I hope that now you have fully understood what will be the unit of reaction. So if you take the concentration of the substance, that is the rate equal to change in concentration by time, it will be, this is the concentration. So concentration, you know the unit, mole per liter per second or mole per liter, and this is time means per second, per minute or per hour. Mole per liter per minute, mole per liter per hour. If you take the gaseous reactions, so where concentrations is given in terms of partial pressure. We have two type of rate, one is in terms of concentration, in terms of gaseous reaction. So in both terms, equations, numericals are giving in the examination, so you have to know both the terms. So for gaseous reaction, what is the unit of rate of reaction? So it will be atmosphere per minute per second or per hour, that is the dP by dt, or delta P by delta T. We can use here delta P by delta T, like this thing. So in terms of partial pressure is given. So for ideal gas equation, we know that P equal to nRT. So P will be, partial pressure will be nRT by V, or N by V is nothing but the concentration. So V is, C is nothing but the W by V, RT by M. So concentration, or we can write here density to RT by molar mass. Suppose partial pressure is given, then we can write mole fraction of the gas in question into total pressure given in the mixture. We can convert this partial pressure into concentration, partial pressure. So interconversion of units, that is the partial pressure can be changed into concentration. How? So PV equal to nRT, so PV equal to N by C into RT. Let me repeat it. So N by P is nothing but a CRT. So C equal to P by RT. So we can convert C into P, P into C, like this method. Now in gaseous phase reactions, so how we can write the rate of reaction? So we can write the rate of reaction like this. So A is the gas which is converted into B gas. So rate of reaction will be dA by dt equal to plus dV by dt. So this is the rate of disappearance of A, this is the rate of appearance of A. And again dA by dt is the concentration we can write here moles by volume, so minus 1 by V into dNA by dt. Similarly for this one, minus 1 by V into and concentration of moles of B by dt. So we can use here concentration of A is nothing but the moles of A by V, and partial pressure is nothing but the concentration of A into RT that we have already seen here. So again this Na is nothing, so Na by V, so Na by V will be your Na by V is nothing but the P equal to ART. So we can add here A is nothing but the PA by RT. So here we put PA by RT. So this will be dA by RT, 1 by RT. And for B minus 1 by RT, this will be dV by RT. This is the instantaneous rate of reactions. Since this reaction is this is appearance, this is the product, so we can write here instantaneous rate of reactant is this is minus dA by dt equal to dV by ds dt, or minus 1 by in terms of concentration, in terms of moles also minus 1 by B equal to dNA by dt, or equal to minus 1 by RT dP by dt. So this is in terms of concentration, in terms of moles, in terms of pressure, all will be equal to each other. Similarly for the average rate, we can write delta P by delta T. So all this will be helpful in solving the numericals. So just go through this thing once again very carefully, so that you can you can solve any type of numericals very easily. So I am giving some numericals also for based on all these type of questions.